Again, with find the angle that corresponds to this ratio, only this time they want us to speak radian as we're doing it, so this procedure won't seem too new to you, I don't think. They want it to the nearest hundredth also, which means they don't expect exact values. We're not going to have to say 3 pi by 4 or anything like that. It's just going to be a decimal. So there will be calculator involvement in the moments to come. Cosine theta is minus 0.5. If cosine is minus 0.5, where are we? Cosine corresponds to the x-coordinates, so if it's negative, we're off to the left. We're in one of these two quadrants. We are not there. We aren't there either. We're in one of these two triangles. Now, you know and I know that this is minus 1/2, and we could probably draw a special triangle, but let's pretend we didn't know that, and we'll just let the calculator do this one for us. So 0.5 second cosine, or on your calculator, maybe second cosine 0.5. That tells us the reference angle is, I almost said 60 degrees, but we can't use degrees for this one. We are supposed to work in rads. 60 degrees is pi by 3. There are several ways to prove that. I don't have room to do it right now, but you can convince yourself of that if you have any doubts. Our reference angle is pi by 3, and it can be either there or it can be down here. The rotation angles, starting at 0 and going counterclockwise, will be either 2 pi by 3 up top, or get around to pi and keep going another pi by 3. That takes you to 4 pi by 3. So there's our two solutions. Okay, cotangent theta equals, okay, I get a stabbing pain in the head when I see cotangent, so let's sort that right away. The reciprocal of cotangent theta is tangent theta, our old friend. And the reciprocal of minus 5 over 4 is minus 4 over 5. That's a little better. So where are we now? Tangent is negative. So everything's positive in that quadrant. Tangent is positive in quadrant 3. We must be in one of these two quadrants, either 2 or 4. And so we either have a triangle like so, or we have a triangle like so. I could label the opposite and adjacent sides. We could work it out that way by building up a triangle, but this isn't one of the special triangles, so we're going to need the calculator's help anyway. I'm just going to go right from here to finding the reference angle. So 4 divided by 5 is 0.8. The inverse tangent of that is, oops, I admit I just did that in degree mode, which was my bad. With my calculator in radian mode, if I have 0.8 and I do the second tangent of it, I get 0.6747 and so on. To the nearest hundredth, that's 0.67 rads. So we have a reference angle of 0.67 radians there, or we have the same reference angle, 0.67, in the bottom right. Now again, those are not rotation angles. We get the rotation angles by doing this. What angle is that? Well, it's all the way around to pi and then minus 0.67. So 3.14159, etc. minus 0.67 tells me that top angle is 2.47 radians. In the bottom right quadrant, this angle is like going all the way around to 2 pi and then backing up by 0.67. So 2 times pi minus 0.67 is, let's see, 6.28 minus 0.67. I get 5.61 radians for the second angle. So same procedure as before, we just have to work with slightly unfamiliar and not very pretty sometimes values for the radians instead of degrees.